So in my previous video I told you how to evaluate definite integrals involving sine and cosine function. So let me give an example now. So to evaluate, say, the definite integral 0 to twice pi of the function 1 upon 5 plus 4 sine theta. Okay. So we consider, because the limits are from 0 to twice pi, so we consider the positively oriented circle mod z equal to 1. Alright, so this is the circle, positively oriented circle C, say, and this is modulus of z equal to 1, and this is the real z axis and this is imaginary z axis. Okay, so with C, parametric form of C is z theta, is radius is 1, so therefore it is just e to the power I theta, where theta varies from 0 to twice pi. So now in the integrand we have sine theta. So what is sine theta? So sine theta is e to the power I theta minus e to the power minus I theta divided by twice I, and so therefore this is nothing but, because it is e of I theta is z theta, so we just write z. So I am not writing z theta, so it is z minus 1 by z divided by twice I. Okay, and from here you see that the derivative of z theta is equal to I times e to the power I theta, and that is nothing but e to the power z, and that you can say that your d theta is just dz by I z. So therefore our definite integral 0 to twice pi d theta 5 plus 4 sine theta, this becomes the control integral modulus of z equal to 1, and 1 upon, it is 5 plus 4, what is sine theta? So your sine theta is z minus 1 by z divided by twice I into I z. Okay, so this becomes, so if I simplify a bit, then you will see that, so twice I, so 2 will be 1 2 will be cancelled out, and 1 I will be cancelled out. This I is multiplied with 5, so it is I can say that this is 5I plus 2 times, because this is cancelled out, this one, so 2 times z minus 1 by z and dz and z. Okay, and if you further simplify, then this is equal to, so this is z cancelled out, so it is 2z square plus 5iz minus 2, and 1z is cancelled out there, so this is dz by this one. Okay, so now we are to look at the singularities of this polynomial, quadratic polynomial, and there will be 2 roots, and if one of the roots or 2 roots are inside mod z equal to 1, then this is nothing but twice pi I times residues of 1 upon 2z square plus 5iz minus 2. Okay, so it is sum of residues of these at the singular points where inside mod z equal to 1. So we will look at this, sum of the residues of this. So let us see what are the singular points of this function first. So now the singular points of this function, the singular points of 1 upon 2z square plus 5iz minus 2 are given by 2z square plus 5iz minus 2 equal to 0. And so that implies you solve it. So if you solve it, then it is twice a is 2 into 2 and minus 5v, this is 5i, and plus minus 5i whole square, so that is minus 25, minus 4ac, so that is nothing but 4ac plus 16, so this is 16. So you see that this is minus 5i plus minus, this is minus 9, so it is nothing but 3i and divided by 4. So this is minus 5i plus 3i divided by 4 and minus 5i minus 3i divided by 4, and that is equal to, so it is minus 2i, so it is minus I by 2, and this is minus twice I. Now it is clearly this root z equal to minus I by 2 is inside mod z equal to 1. The other root minus twice I is outside because the modulus of this is 2, so, and our radius is 1. Okay, and modulus of this is half and this is inside. Okay, so now we need to evaluate only the residue of the function 2z square plus 5iz minus 2 at z equal to what? Inside singular point, so it is minus I by 2. And now you recall that this is pz by qz form, where this is your qz, and you see that z equal to minus I by 2 and minus twice I are the distinct roots, so there is a simple pole at minus I by 2. So what is the residue? So residue z equal to minus I by 2, so the residue of this one, so this is nothing but your z derivative of this one, so residue is nothing but derivative of the denominator, so denominator is 2 into twice z plus 5i, and the numerator is 1. So residue is nothing but this one evaluated at z equal to minus I by 2. And what is the value? So you see that this is 4 into 4z, z equal to minus I by 2 plus 5i, and that is equal to 1 by minus twice I plus 5i, and that is equal to 1 by 3i. So you see that the residue is this. Now here, so from here we have seen that from this equation, so thus you can see that 0 to twice pi d theta, so 5 plus 4 sine theta equal to twice pi I times residue of this function at the singular points which are inside, but there is only one singular point and we got the residue as 1 by 3i. So this is the value of twice pi by 3, and which is the value of our definite integral. Okay, so you can try 0 to twice pi d theta and 5 plus 4 cos theta, see, and also you try and d theta 5 plus 4 sine twice theta. Okay, thank you.